All right, I think we're ready to get started. Thanks for attending this session. It's the last one of the day. I'm really happy to see that you all showed up here, and I noticed that most of you have a beer in your hand, so halfway through this talk, hopefully it'll be better than the start. So we'll talk about busting some myths with Xamarin. How many of you are doing Xamarin development today? About half? Any iOS and Android native developers? A few. So hopefully you'll get an idea of what it's really like to work with Xamarin. I've been working with Xamarin projects all over the world for the past few years, and let's see if we can bust a few of these myths. Before we get started, my name is Filip Ekberg. I run a consulting and training business in Gothenburg. I'm a Microsoft and Xamarin MVP, so that basically means that I talk a lot about Microsoft and Xamarin, and I try to do my best at work. If you have any questions, please feel free to send me an email or ping me on Twitter, or just grab me afterwards and we'll have a chat. So, we are here to talk about Xamarin. I don't know if you noticed, but about 8-9 months ago, Xamarin got acquired by Microsoft, which means that larger corporations that were previously hesitant to work with Xamarin can now more easily get into that product. Because I've been in projects where reasonings behind not choosing Xamarin as a technology was because it was a small company, it was only a few hundred developers. What happens if Xamarin no longer wants to build their toolkit to support iOS and Android? The idea with Xamarin is that we can build apps for all the different platforms out there. And they provide the tools for us to be able to target iOS, Android, as well as any other .NET application out there. So the promise is that if we know C# and .NET, we'll be able to simply build an app for any given platform using C# with the Xamarin Toolkit. That sounds pretty awesome, doesn't it? But it's rarely the case, right? So we'll talk about some of the problems that I've faced when working with Xamarin, some of the problems that I had when I started working with Xamarin, and some of the problems that I'm still facing when I talk to new developers that want to get into building apps with Xamarin. So one of the first things that comes into mind when we talk about building cross-platform applications, it's what have we done in the past? In the past, we've been able to build apps for all the different platforms using technologies like PhoneGap or Cordova, which is essentially a way for us to use HTML, CSS, and JavaScript to target these different platforms. But these technologies have their lack of features. And sometimes they lack performance because they're written in HTML, CSS, and JavaScript. So they're not running on the actual device. So one of the first misconceptions with Xamarin is that it's not really native. But what happens is that when we build something in C# and .NET and pass that through the Xamarin Toolkit, on the other end we get a native compiled binary, which means that we get a native user interface. If you create a button in Xamarin, you compile that, and then you run that on your iOS, Windows, or Android device, it'll look like whatever you built on that native platform with the native programming language. It means that if you're a Swift developer and you build an iOS app, if you translate that code into C#, it'll look exactly the same. What's interesting here is that when we build something with a third-party toolkit that is supposed to help us reach a larger variety of devices, with less people and less code, we don't want to compromise the capabilities available on that platform. So it means that we need to be able to use all the capabilities of the devices. So if you're using an Android device or if you're using iPhones, you might want to use the particular things on those platforms. On iPhone, you have Touch ID. On Android, you have proximity sensors and stuff that you might not have available on iOS. Using Xamarin should not be in your way of using those capabilities. So the idea here is that we get a totally native app. We get our native user interface. We get access to all the native APIs. And I've been in projects where we have a vendor that sends us a Objective-C compiled library, and we're using Xamarin. And the first thing that we thought were like, why are you sending us like a compiled Objective-C binary? We're using C#. But the idea here is that we can still use that if we use Xamarin. So whatever API third-party vendor sends us for that particular platform, we can still use that in Xamarin. And if it's a native user interface and we have access to the native APIs and it runs just as a native app would, means that we have native performance. Means like the app feels and behaves and looks just like the app would if you wrote that in Java or Swift. Just means that we have less developers and hopefully less code. So this is native. Like this is a truly native application. Something funny here is that plenty of times I've taken a Xamarin application. In fact, I didn't tell the people that I showed the app that this app is a Xamarin application. So think of these people that I showed the app as native developers. I took a native developer. He worked in Swift for a long time. I showed him my app, and he told me, this looks like an awesome iPhone app. You're conforming to all the design guidelines of iPhone. You're using all the right APIs. It feels snappy. We can go between views and transitions are beautiful. And then I tell him, well, this is Xamarin. Here's the same app for Android. All of a sudden, there's so many problems with the app. They find performance problems. It no longer looks like an iPhone app, according to them. So what I'm trying to say here is that one of the misconceptions with native developers is that just because you're not building something in Swift or Java doesn't mean that it's not running on the native platform. So if you come from a Java or Objective-C background, look at Xamarin like a way for you to share code across the different platforms without compromising the quality of your app. But it does take a while to get there. So if I tell you that you can have less code, you can now go ahead and fire half of your developers because you just need one team, no longer need two teams. If anyone's a manager in here, you're probably super happy now. But there's no silver bullet, so that's not going to happen. You still need a lot of information and a lot of knowledge from those native developers to be able to reach the same capabilities and performance and look and feel of your apps. So, Xamarin is not always the answer. It sounds like it's super awesome, but the fact is that you need to know C#. If you're coming from Swift or Java, adhering to .NET and C# and learning Visual Studio and learning all the toolkits, that's like a stepping stone in the right direction, but it's probably not enough. It'll take you some time to adapt to that new development environment. So I'm trying to say that C# is not enough. We need to learn more about these platforms. I still talk a lot about the native developers, and I talk to a lot of native developers, and their key strength is that they have so much knowledge about these different platforms. So I've been in projects where we had very specific problems on very specific platforms and very specific devices. One of those projects, we had this idea of building an app that dynamically loaded images based on your density of your screen. That means that the better the phone, so if you had the newest iPhone 7, you would get super crisp and clear and beautiful images. It would probably take forever to download because the images would be a few megabytes. And if you had a worse phone, or not as good phone, you would get lower resolution images. The problem that we were facing here is that even if we were using C#, we had the way that we fetch these images from the web. They're all in shared code. They're all in C#. It's using all the libraries that we're used to as .NET developers. But our problem was that we lacked the understanding of how does memory management work across the different platforms. We were just using these phones like they were a quad-core computer with 16 gigs of RAM. And that's rarely the case for a mobile phone, at least. There are phones that have a lot of memory and a lot of processing power, but we need to think about the form factor of the device. Every for loop, every if statement, that's going to go down and take a little piece of your battery. So what were we finding out when we did this thing with these different devices and these dynamically loaded images were that it worked fine in all the simulators and emulators, but then we went on and published these to a variety of different devices, and one of them had a problem. One of the newest phones on the market at that time, we found out that we had a problem because it didn't handle the memory properly. So on that particular Android phone, We were too quick swapping between views. We were leaking a little bit of memory. But the older phones weren't as fast as transitioning between the different views, so it had time to clean up after itself. But on this newer phone, we had super big problems because it loaded in a lot of large images. We had a memory leak, and it didn't clean up after itself. So that means that we had to drill down into that native Android platform. We had to learn about how do we debug the app when it's running natively on the phone. How do we inspect that? How do we profile that? How do we fix these memory problems on that particular Android phone? You see that knowing C# in this case is not enough. It means that we need to have a broader understanding of what it's like to work with mobility and mobile devices. Because ultimately, these platforms are very different. So I have these three different platforms here. So we have Android, iOS, and Windows. They all have a few things that look very similar. So if we talk about the application lifecycle, they all have that idea of how to start an app. What happens when the app launches? What happens when it goes into sleep? How does it resume from being in the background for too long? Even though it says application lifecycle on all of them, they're totally different. Android has their own way of handling when the app starts and when you transition between views, and you don't know if the app is in the background because the idea is that the app should just work all the time. And then we have UI quirks. Imagine building pixel-perfect apps for all these different platforms. What does a pixel mean on Android? What's a pixel on iOS? And how does that transition into a universal Windows app? And then, of course, we have memory management, which works very different between iOS, Android, and Windows. And the Windows part here, we could probably break that down into even more parts. We can talk about building apps for the Windows Phone. We can build apps for Windows Desktop. We can do HoloLens apps. And they all share their own part of this API here, but they all have their different life cycles. And then, of course, there's the things in the middle here that looks like they're different, but it's the same concepts. They're just called different on these different platforms. So for instance, on Android, we have a concept called activities. And we have view controllers on iOS, and we have pages on Windows. Both Android and iOS pretty much use an MVC pattern, while Windows uses an MVVM pattern. So imagine if you work one level above that. You work in Xamarin and you try to abstract away the idea of the native patterns. So you try to use a pattern for all the different platforms, but you still need to understand the underlying patterns that are used on those platforms. Because ultimately, when Xamarin compiles your app, on the other end, you get a native application that's pretty much the same code like you would get if you built that in Java, Swift, or Objective-C. So I do know that it feels a little bit discouraging, saying that, well, if you're all .NET developers and now you want to go and build all these awesome applications, you felt like you want to ride this app wave, you want to be the next app millionaire, you're off to the best start, because knowing C# means that we can have one team working on the app. The promise is still there that we can use Xamarin to target these platforms with one code base, with one team, which targets multiple platforms. But it's not as easy as if we were using HTML, CSS, and JavaScript and just said, we're going to target all the different browsers. That's not the same thing as using Xamarin as a toolkit to target your different devices. So you can compare Xamarin to a developer with what Scrum is to a project. You have Xamarin as a toolkit to help you reach this goal of you want to build awesome apps for all the different platforms. While Scrum is a way for you to make sure that your project delivers your product in an awesome manner. You can't just take Scrum and throw that on one project and hope that it works. So it's a toolkit that will help you build your app. So this app here is built using Xamarin. If I didn't tell you that this was built using Xamarin, you probably wouldn't notice. It uses the platform-specific design guidelines. So if we look at Android on the right here, you'll see that we have this green button at the bottom called the floating action button. That's a material design thing. The idea is that I tell Xamarin that I'm building a Xamarin application. This is Android. You can put an action button somewhere, and it'll translate that into what we see on iOS and the floating action button on Android. So that's the basic idea. And we can see here that it's using different UI elements on these different devices. So I guess the idea here is that we can still build these UIs and be very UI specific and make them look really well and have nice animations, and there's no friction between us and what we can build for that platform. But we do that with shared code. So the idea is that we have one team, one code base, and we do all this in C#. So what does it really look like? What happens in our app? Like in the best of worlds, we would still have these two platform-specific C# projects. So when you set up your first Xamarin application, or if you're already working with a Xamarin application, the idea is that you have one project per platform. It's just to know how to build the binary and what kind of settings and splash screen and other things that you need to specify per platform. And then you can also do the tweaks per platform in that project. Then the idea is that everything in our app, transitions, when I say transitions, I mean how do we go between pages, not the actual animation, but when do we transition between certain pages in the app? How do we communicate with our backend? All that is supposed to live in your C# shared layer. That's the idea of Xamarin, at least. Most of the apps that I've worked on, it's the other way around. The biggest part is the platform-specific parts, and then you just have one little shared project at the bottom. So the idea with Xamarin just solving all your problems, it's not going to happen. Like you're not going to reach a perfect architecture just because you choose Xamarin. You can still have a product owner that tells you, I want to focus on Android this week. Let's just skip iOS for now. And then you have developers that go into your Android project and build everything in the Android project instead. And then when iOS comes around, either you have to refactor your Android project and put everything in shared code, or you need to put some effort in the first place to put everything in shared code. Like it depends on what type of project you work on. But most of the times I've found that you work more in the platform-specific projects than in a shared one. So for the past 8 months, I've been working on a project in Gothenburg. The idea behind this project is that we deliver an app that lets you purchase tickets for the public transport. The app looks like this, and it's not Xamarin's fault when the bus is late. Just have to say that. I do get blamed for the bus being late when I tell people I built this app. So the idea here is that we built this app, and they had already made a lot of great decisions when I came along in the project. But what they've done is that this app is built in Xamarin. The UI looks very similar between these different platforms. It's a very UI-heavy application. Even though the app looks very similar, it's two very separate projects for specifying the UI. If you read anything about Xamarin, you're probably thinking, well, you could probably build something that shares the UI across the different platforms, since it's very, very similar on both of these phones. We could, but we would end up having a lot of other issues, and I'll talk more about that soon. But the idea here is that we can be very specific for each platform. If we have custom animations on Android and iOS, we can make sure that they render properly on each phone. Because just as with Windows that you have different form factors when you build universal Windows platform apps, on Android you have a trillion different form factors and processors and amount of RAM and all the different permutations of Android devices out there. It's pretty much crazy. So let's just have a look at what it's like to work with a Xamarin project. So I'm running this on a Mac here. So one of the first things that you need to do is get a Mac, which is kind of a hassle if you don't already have one. You need the Mac because Xamarin needs it to compile iOS. There's still limitations on where you can build an iOS app. That's restrictions from Apple. Would I recommend Visual Studio or Xamarin Studio? It depends on what I want to do. So I'm showing this here in Xamarin Studio, but all of the other times that I've done Xamarin demos and Xamarin talks, I show it in Visual Studio. So I just want to spice things up here. And lately, I found that the tooling in Xamarin Studio, when working with iOS apps, is heaps better than if I work on Windows. Most of the time when I work with Xamarin, I have my Mac sitting over there, and I have my much better PC sitting here in front of me, and they communicate over Ethernet or Wi-Fi. What happens is that when I press compile in Visual Studio, it takes my entire solution, ships that over my network, compiles that on my OS X machine, Mac OS, and then starts the app through Visual Studio. The debugger hooks into my Mac. You see that there can be a bit of problems. And if you're on a dodgy enterprise Wi-Fi, it's better to just use your Mac. Get used to Xamarin Studio. And I find the UI a lot better now. Like, they've done a lot of changes. They've changed all the icons. That was a big thing, apparently. So all the icons in Xamarin Studio were newly hand-drawn. Doesn't make me a better coder, but that's the way it is. So here we have a Xamarin solution. So the idea for this app is that I have an app that I can add reminders in. It's a basic to-do app. And I have this available for both iPhone and Android. And these three different projects here, they give me different things. So we have the iOS project, which is clearly a way for us to build and run and compile and debug our iOS app. We have the Android app, which does the same for Android. And then I have a shared project. The shared project is where I put all my shared logic that goes across these different platforms. Now, for a simple to-do app, there's not a lot of things going on in the shared code. But it kind of proves a point. So I have 3 files in here. It's like a repository. It's my model. It's a way for me to handle login because I want an extra file. So that project is very small. And then we take a look at what goes into our iOS project. All of a sudden, we see things here that we might not have seen before coming from a .NET background. We see things like view controllers. That's a very iOS-specific concept. And I mentioned before that we have all the APIs available to us when we work with Xamarin. And what's pretty cool here is that all the APIs translated from Objective-C or Swift, they're just C-sharpified, which means that if you're an iOS developer and you know C# and you know how to work with iOS, you'll just automatically know how to work with Xamarin. Because all the APIs look exactly the same, but it looks like C# instead. So an example of that is we have something called the UI view controller. The UI view controller is a concept from iOS, and it's called the same here. It's just in C#. And then we have other things in here as well that builds up the app and lets us work with iOS. We need to learn more about how do we set up different sizes of images. It's funny, historically with iOS, they said that you only need one form factor, you only need one screen size. So why would we build a tooling around building this for different types of devices? Then the next generation iPhone came out, and all the images, they appended at 2x to all the naming, just to make it a little bit bigger. Then they made the phones higher. So they had another one. It's at 2x dash some number. Then they had another one, and so forth. So you need to learn all about that. You need to understand how do I make different sized images for these different platforms, and that's just for getting started with iOS. If we then look at Android, we have concepts from working with native Android. So if you're a Java developer coming from an Android background, you'll be familiar with something called activities. So we can go into an activity here. We can see here that it's setting up something called the onCreate. That's the application lifecycle specific pieces to work with Android. So let's just run this here and see what it looks like. The code isn't the most important part. The important part here is that you notice that there's a big difference between these different platforms, and that we have the specific APIs for that platform in that specific project. So you notice here that I got a nice loading screen here, and we have this login screen here. So we can do login here. I can click up here to add a reminder. We see here that it's using all the native transitions. Everything looks and feels like an iOS app. It's not the most beautiful one, but I'm not a UX designer. I'm a developer. I can click that and it gets rid of my reminder. So now if I run this same app, I'm going to close this up here. I'm going to set the Android project to the starter project. I'm going to run this here in the new Google emulators. I don't know if you worked with Xamarin or with any Android development in the past, the emulators have been a big headache. Like, they've been horrible. But now they've finally reworked all the emulators, so they're using hardware-accelerated stuff to make it work better, and they're just as fast as Hyper-V on Windows, for instance. So we immediately notice a difference here. So this is the same app running on Android, but I had to build the UI twice. So I have my view controllers on iOS and my activities on Android. Question? Why didn't I write this in Xamarin Forms? That is the next thing in a few minutes. Very good question. Notice here that when I click the username and password, it kind of uses the username and password as placeholders in these different labels. We didn't have that on iOS, because that's not a design principle that iOS uses. But on Android, material design tells us to do that. So I simply specified my UI explicitly for Android and explicitly for iOS, and that gives me full control over the UI. So I can log in here as well. I can click my floating action button here at the bottom. Comes up here in the list. I click that, and you see that I get a snack bar here at the bottom. So straight away, we see here that I get a much better experience on the Android device. I'm not saying that Android is better, but it is. In this case here, I just got this much better experience. All right. So we saw here that knowing C# is not enough. And this dialog should not be there. So knowing C# is not enough. We need to know how do we set up a view controller? How do we work with activities? What should happen when in my different application lifecycle events? You can learn all that. But one of the biggest problems that I've found working with Xamarin, learning Xamarin, and getting to know other people that work with Xamarin is that whenever we go into a meeting with a salesperson, they promise that any C# developer they have on their floor can build a Xamarin app. And that's a lie, because that's not going to happen. You need to invest time and effort into learning about those particular platforms. Even if you know C#, you need to learn the APIs. I started out with Java a long time ago, and when Android came around, I didn't just automatically know how to build Android apps. Same thing. So now someone comes up to us and tells us, let's do Universal Windows Platform. This is just, let's imagine this would happen, because it doesn't really happen that often. I've had the questions a few times about apps built in Xamarin, which they want to port over to Windows. And then I tell them how much time it's going to take, and they don't want to do that anymore. The promise is that if we were in a perfect world, we would have a small platform-specific project per platform. And that would mean that we could simply add windows. But in our case here, if we look in Xamarin Studio, what we had was just a model in a repository in our shared code. All the UI was explicitly written per platform. So that means that you would have to do the same for Windows. That's when the sad faces come out. You told me this was cross-platform. It is cross-platform, because you can run your shared code across different platforms. But what's not cross-platform is how the different devices work, the different design guidelines for those different platforms. But of course there's an answer, and we've already talked about, or you mentioned Xamarin Forms. So the idea here is that let's add an abstraction. Why would we have to write the UI 3 times or 4 times, or how many times do we need to write the UI, right? We should just have to do that once if the app kind of behaves the same. Most of the time, all you care about is, I have my UI, I want the user on that particular platform to feel familiar with the app. I want them to feel like it's an app built for that platform. So the idea here is that we can simply add more platforms as we go along, and we have a very large shared UI code base. So the app that I showed you before, this showcase app from Xamarin, is in fact built using Xamarin Forms. Probably couldn't tell. So we get a very nice chart, we get like a table of data, and then on iOS we have the tab bar at the bottom, we have the hamburger menu on Android, and I can't remember what it's called on Windows, but no one uses that anyways. So we can still use this on all these different platforms. It's great. So the idea here is that we add one more layer, an abstraction between the shared logic that still goes across the different platforms. Why would we not put those two together? Because you might want to share your application logic or share your contracts over NuGet packages. You might have a backend written in ASP.NET that uses pretty much the same backend. So the idea here is that you have a shared UI layer that's very much Xamarin specific, but there's an abstraction between how that translates into the specific platform. So think of it like this. You use XAML. Xamarin Forms is all about using XAML. So you build up your UI saying, I have a page here, I have a button on the page, it's up to Xamarin to decide how this renders per platform. That sounds pretty good. That means that I can simply have one file that specifies what this particular page should look like on a conceptual level. But you start adding frictions. You have more friction between you and the platform. You add one more layer, you get one step further away from total control of that platform. Which means that you need to know the limitations of working with something like Xamarin Forms. So let's just have a quick look at a shared UI using Xamarin Forms. So I'm still in Xamarin Studio here, but you see here at the bottom that I have a universal Windows platform app. I'm not going to show any magic here. I'm not going to be able to build this on a Mac because it needs to run on a PC. But if I start parallels here now, it's going to sound like it's a shopper over here because the fans are going to get loud. So I'm not going to do that. So the idea here is that projects in Xamarin Studio and Visual Studio, they round trip. So you could have a Windows developer focusing on Windows. You work with the same repository. You check into the same place. You work on the same solutions. But most of the code should live in the shared project. So we still have our models. We have one model in this case. Have one repository. I just added the folders to make it look better. But then we have pages. So we have something called a login page. Guess what that's doing? Lets us specify how to log into the app. So this is a conceptual definition of what will my page look like. I have a login page here. The title of this page is going to be login. I'm going to specify something called an entry. An entry is a way for me to enter information into my app. It's like a text box. Maybe it translates into a UI text box on iOS. Maybe it translates into a XML text box on Android. I don't have to care about that. And then I add a button, and then I introduce something called a stack layout. A stack layout is a concept that's not available on iOS. So what's happening here is that we have controls available that conceptually solve problems that are pretty common across the different platforms. A stack layout lets us stack items on top of each other or after each other. But there's nothing like that out of the box in iOS. So what Xamarin did here is that they introduced a bunch of controls that translates into something that will look great on that platform. But again, you're getting away from the platform. You're trusting that Xamarin takes care of the translation and that they take care of the memory management because there's now one more layer between you and the native platform. Still going to be a native app. It's going to compile down to whatever it would if you wrote the same code yourself. So let's just run this app here. All there is in the platform-specific projects, we can have a look at iOS. iOS only contains pretty much one thing. It's this line here. We were saying here that we just want to initialize the app. Then Xamarin takes care of the rest. It translates our page into a UI view controller or something similar, a UI view, and then translates all the button into the correct things. That's super simple. So that means that as a C# developer, if I've done any SAML or any WPF, this will be a lot easier to work with. So we're kind of getting closer to the promise that if I'm a C# developer, it'll get a lot easier to start working with Xamarin. So I'm going to run this here. It's going to pretty much look the same as the other app did. We have this nice loading screen here. I can log into the app. I have the plus sign here at the top. I can create this here, get rid of it. I can navigate back. And you see here that it's adhering to the native UI principles. It still looks like an iOS app. We have these rounded corners. The margins are a little bit off, but we could tweak that. So what does this look like on Android? Remember, we had a premium experience on Android before. Hopefully, we still have that. But since the idea is that we no longer make any platform-specific UI, that we're doing this in a shared code library now, there's probably going to be a few differences here. The first thing that you'll notice is that these entries here, they're not using the material design placeholder principle. So if I click this here, it's just going to look like a boring text box. I have to get rid of that myself. I can log in. We no longer have the floating action button. It put that up at the top instead. I can click it. And of course, I could get this to understand how to translate that thing into a floating action button. I can bring in some third-party NuGet package that just solves that for me. But doing that in Xamarin Forms means that that principle needs to translate into every platform. If I say that I want a floating action button, what does that look like on an iOS device? How does that work on Windows? But what I did add, I did something different. If I click this here, I still get the snack bar. So how did I do that? Well, since Xamarin is translating all the controls into what the native UI will look like, there's probably a way to just jack into that. So what I've done on the Android device is that I've introduced something called a custom renderer. A custom renderer is pretty much just a way for me to say, whenever you see this control on Android, because this is in the Android project, I want you to do this instead of using the default way of introducing a list view. So in this case here, I'm simply saying, whenever you see this to-do list view, just use this file here and introduce all this code here to simply get that little snack bar showing at the bottom. So what you'll find is that when you work with Xamarin Forms, if you're not happy with what Xamarin translates your code into, you'll spend most of your time creating these custom renderers for each platform. And what happens then? Your platform-specific projects start growing. So you have to consciously make the decision when you start building your app. Are we building a line of business app where we don't care too much about the UI? Or are we building an application where we really want to focus on the UI? Then maybe we shouldn't use Xamarin Forms. It's okay that we build this app per platform. All right. So you all probably feel like this now. Xamarin is awesome, and then you're like, probably not. But it is pretty good. Like, I love working with Xamarin. But it pretty much boils down to the battle of code sharing. Do I want to share 100% of my code using Xamarin Forms and live with the fact that I might have to, not care too much about the UI? Or do I want to go the other way and focus a lot of on the UI, but it'll be harder if I need to add more customizations per platform or even add more platforms? You'll end up seeing things like this. Most of the time in your shared projects, you want to say, if this is Android. A good example is if you work with networking on Android or iOS, they're fundamentally different in how that's implemented and how they support certain things on the network layer. So you could say in your shared project, if we are running Android, I want you to do this particular thing when you talk to our backend. If you're iOS, just do whatever you want. An alternative to this is to use patterns like an event aggregator. You can publish events inside your app instead. And then you can simply handle that accordingly, which means that you can get a nice separation between your UI and your shared code. So there's always ways for you to communicate back and forth between your apps between the shared logic and the platform-specific layer without having to do that. So there's patterns to solve all these problems. I haven't talked too much about async and await in Xamarin, but let me just tell you this, that if you work with Xamarin and you do Android, async and await is interesting, to say the least. You'll find that you're going to get weird behaviors. So if you want to know more about building async apps that are really efficient, I have a talk tomorrow at 3:40. So just come to that and we'll have a chat about how you can build more efficient async apps. Like ultimately, Xamarin makes me a much happier developer. Like I can work in a programming language that I personally love to work in. I can work with my productivity toolkit like ReSharper. I work in Visual Studio. I can use all the different tooling and CI pipelines and whatnot that's available for Microsoft. And it just works. I don't have to focus on learning more about Objective-C, Swift, or Java. Even if I love learning about languages, I can still focus on delivering products. I just have to know what kind of platform I'm building for. So don't be discouraged by the fact that there's a learning curve. Be encouraged that you don't feel like you have to know Xamarin just because you know C#. Because I know when I started, it felt like, well, I should probably know how to do all this because I'm a C# developer and I've been doing this for a long time. But the fact is that you need to learn about all the different platforms. So just to summarize, Xamarin is awesome. It's a toolkit that we can use to build these applications for these different platforms. In the long run, it's not a silver bullet, but it's still a toolkit that helps us build these apps quicker, hopefully cheaper, because we can reduce the amount of shared, the amount of code that we have to rewrite per platform. It's always a problem when we have multiple different teams building the same app, but they have totally different Scrum Masters, they have totally different product owners, because they're totally different platforms. But it's the same idea across two different platforms, right? With Xamarin, we can kind of erase that line between the different apps and just focus on building these awesome apps. Thanks a lot for having me here. It's been awesome. Now let's go and have fun and enjoy the rest of the conference.